Okay, well, what's up, Pranav? I'm going to be teaching you trig substitution today. It is a very common technique in AHL papers, and based on the trajectory in our class, we are not going to cover it anytime soon because we've not done trig yet. So I think it's important I teach it to you, especially since you know sine, cosine, tangent. As long as you know that in Pythagoras' theorem, you should be fine. And let's start. So, you know how an integral looks, right? You have the integral of some function g, for example, dx. And what this does is it gets rid of the derivative. So I can say f of x is equal to the integral of f prime of x dx. And in this case, g of x would equal to f prime of x because that's the derivative function. So that's what an integral does. I'm sure you've already learned that. And a trig integral looks something like this. Let me just write everything down. X squared minus a squared. There we go. So, give me a sec. Okay, so the thing to notice is if you see a square root and then some number, for example 9 minus x squared, or 9 plus x squared under square root, or even x squared minus 9 squared written in this form, you need to use trig substitution. So whatever you've learned about u substitution will not work here. You will not get an answer from u substitution, and the examiner will give you 0 marks because that is a wrong technique. So what exactly is a? A is a constant, and usually it's a constant that can be square rooted to a whole number. So a can be 1, a can be 4, a can be 9, a can be 16, a can be 25, and so forth. A cannot be 3 because the square root of 3 is not a whole number, it is irrational. So those are the constraints we have, and in AHL it will usually follow this pattern. X is just a variable because we're integrating with respect to x. So I'll show you an example, but before we get to that, let's look at a simple triangle, a right angle triangle, and say this angle here is theta. So if we look at the first example here, a squared minus x squared, a is going to be our hypotenuse and x will be our opposite side. Why is that so? Let's say this is k. And we don't know what the value of k is, but we know what a and x are. So k squared plus x squared is equal to a squared, Pythagoras' theorem. To solve for k, we would do the square root of a squared minus x squared. And you can see how this is identical. Oops, wait, what? Give me a sec. Hold up, my bad. And you can see how this is identical to this right here. So we get that expression from a right triangle. Now let's try an example. Let's say I've got the integral of 1 over the square root of 9 minus x squared dx. If you want, you can watch the rest of the video, or you could follow my steps and write this. Just take a note of everything here because this is very important. And whenever you approach a trig substitution question, I would always advise you to draw this triangle here. Let me just always draw this triangle here because that is very important. Anyways, so we've got this, and 9 minus x squared looks very similar to a squared minus x squared. So we can write the square root of 9 minus x squared is equal to the square root of a squared minus x squared. And you notice how this is a squared. We need to make 9, we need to square root it and then square it. So 9 is equal to 3 squared. Therefore, we get the square root of 3 squared minus x squared. Perfect. The next step is to not make a substitution yet, but to understand why we do. And we use a right angle triangle. And theta is always going to be this angle down here in the bottom right. We don't need to have theta here. We put theta here just to be consistent with our working. So notice how we're subtracting 9 minus x squared. So the hypotenuse needs to be 3. And why is it not 9? Why is it 3? Because we're squaring 3 and then square rooting it based on Pythagoras' theorem, which is a squared plus b squared is equal to c squared. So the hypotenuse would be 3, and 3 squared would get you 9. So that means our opposite side, this side right here, is just going to be x. So we can use our trig ratios. Sine of theta is going to be opposite. Opposite is x over hypotenuse, which is just 3. And solving for x, we get 3 sine theta. If you can understand up to here, you will be fine. You can solve trig substitution questions. But if you don't understand this important step, then I advise you to watch other videos or, ask me more questions so I can make another video on this. So you know how you have a u substitution in an integral? You can say u is equal to like 2x squared. And the next step would be to differentiate u with respect to x, right? Well, it's gonna work very similar here. We have got our x. Now we differentiate x with respect to theta, so dx over d theta. And the reason why we do that is the same reason we differentiate u with respect to x in a u sub question. So the derivative of sine is cosine. So dx over d theta is 3 cosine of theta. And if you're just wondering why is it dx over d theta, you see our expression is x is equal to 3 sine theta. So the function outputs x, and we're inputting a value theta, so we divide it by d theta. It's similar to dy over dx in a function that may look like this. F of x is equal to whatever, 2x squared, right? So we solve for dx. That's 3 cosine theta d theta, and we substitute everything into our integral. Our original integral was 1 over square root of 9 minus x squared dx. So that's 1 over the square root of 9 minus x squared. And x is equal to 3 sine theta. So 9 minus 3 squared, which is 9. And then sine theta squared, which is sine squared theta. All of this multiplied by dx, which is 3 cosine theta d theta. And now solving this might seem very scary or, impossible. You might need a lot of steps, and that is true. But these are very simple trig steps you've probably learned in 10th grade. And if you apply them properly, you can get a question like this correct. And remember, this is the basics of trig sub. So you need to make sure you're familiar with everything. Otherwise, you will not be able to master this topic anytime soon. It is very important you understand everything I say before school starts. So let's look inside the square root. Let's simplify this expression because it's crazy. We've got a lot going on. So let's work on what's inside the square root. So we can factor out a 9 and write that as 9 times 1 minus sine squared theta. And we can do something with this because we have this identity, sine squared theta plus cosine squared theta is equal to 1. And if you're wondering where we get that from, if you don't remember, it's from our unit circle. So say we've got 4 quadrants. We pick a random point up here. We have an x realm and a y realm. So this is our x coordinate and this is our y coordinate. And we have an angle to the x-intercept called theta. And we have our hypotenuse, which will always equal 1 in a unit circle because a unit is always 1. That's why we call a unit circle, because the hypotenuse will always be equal to 1. This is an established fact. So therefore, our x-coordinate will be cosine theta because it's adjacent, and what's opposite is sine theta, so that's our y-coordinate. So if you use Pythagoras' theorem, you get sine squared theta plus cosine squared theta is equal to 1 squared, which is just equal to 1. That's a derivation. So I can rearrange this to get cosine squared theta is equal to 1 minus sine squared theta, which matches what we have in the bracket. So this is actually equal to 9 cosine squared theta. And we make that substitution in here. So we can rewrite our integral as 1 over the square root of 9 cosine squared theta, because we simplified that. And we still multiply that by 3 cosine theta d theta. Yes, 3 cosine theta d theta. And you see how we've gotten rid of the x and we have everything in terms of theta? That's what we want for now, but then when we solve the integral, we will convert it back to x, as you would do in a u substitution question, right? So this, again, is equal to 1 over, what's the square root of 9? The square root of 9 is 3. And the square root of cosine squared theta is just cosine of theta. And now conveniently, these cancel out. And you're just left with the integral of d theta, or 1 times d theta, which is just d theta. So you see how we've converted this very daunting expression into d theta. You've realized that all of this inside is just equal to 1, and that's what you do in trig substitution. You convert something that's very complicated to something simple, using trigonometry, obviously. And now we're going to integrate that. So the integral of d theta is just theta plus c. And we said earlier, up here, we said x is equal to 3 sine theta. So I'm just going to write that again. X is equal to 3 sine theta. And we need to solve for theta to substitute it. So we can say sine theta is equal to x divided by 3. Therefore, since theta is equal to sine inverse of x over 3, or a better way to write this as an AHL student is arc sine of x over 3, which means our final answer is going to be arc sine of x over 3 plus c. And that is the answer. And you know, if you understand this, then there is a shortcut you can use to solve a question like this in seconds. And it would be right here in the formula booklet. And I will write this down in the page. It is this. So take note of this, write it down in your notes. I'll also write it down in my notes. So I'll just label this as notes. It is the integral of 1 divided by square root of a squared minus x squared dx, which is equal to arc sine of probably a over x over a plus c. And then we have a condition, right? So this condition we always have in math, right? We have in geometric series, etc. So see how this form is very similar to our final answer, x over 3. And a is to 3 because our original expression was 9 minus x squared, and that is basically 3 squared minus x squared. So a would equal 3 in that case. So you, without doing any of this, you could have just used the formula booklet. But the reason I showed you this is because in AAHL, they will give you problems where all of this applies, but it will not give you your final answer. Because the question will be more complicated and it will make you use this exact process. In other words, you need to use this exact process I showed you to solve an AAHL style problem. So I know this video is already long, but I'll go over an AAHL question with you. If you can give me 1 minute, I'll find it. It is going to be this. This is a past paper question. I believe it's like 8 marks or so, and you will see why. So I will sort of speed run this while explaining. because you don't have much time in an exam. So this is the expression. So you see, we can't just use arc sine of x over a plus c because we have x squared on the numerator. So using that is not possible. So the first step, I will tell you this again, is to convert the square root of 25, okay, my bad, minus x squared into a squared minus x squared, which is equal to 5 squared minus x squared. That's the first step. So you need to get your a. So you can just write a is equal to 5. The second step is to draw a right triangle. You label this as theta. You notice 5 is the hypotenuse, x is our opposite side. So sine theta is equal to x over 5. Therefore, our substitution is x is equal to 5 sine theta. The third step is to differentiate x with respect to theta. So that would be 5 cosine of theta. And then you solve for dx so you can make the substitution. The fourth step is to plug everything in. Okay? So you get x squared, and we defined x as 5 sine theta. So that squared is 25 sine squared theta divided by the square root of 25 minus x squared, which is what we wrote, right? X squared is 20 minus 25 sine squared theta. It's a lot, and then you multiply this by dx, which is 5 cosine theta d theta. Okay, now this does seem like a lot, but bear with me. The next step is to factorize whatever's in the square root. So that would be 25 times 1 minus sine squared of theta. And if you remember, we had this expression earlier from the unit circle, right? So cosine is equal to that. So that's 25 cosine squared theta. So you can, fifth step, it would be to just substitute that into our integral. So that would be the square root of 25 cosine squared of theta. Okay? Yeah. Times 5 cosine theta d theta. And you can see this would equal to 25 sine squared theta divided by the square root of 25 is 5. Oh God, okay. The square root of cosine squared is just cosine times 5 cosine theta d theta. And what I love about trig sub is if you'll know you're doing everything right if your numerator cancels with the denominator you just simplified. If that happens, you are doing everything right. And say you can't solve this question anymore. If you get to the fifth step, or sorry, the sixth step, I should have wrote that better, you will get about 4 out of 8 marks, which is still very good. But we are here to get full marks, right? So now this is equal to the integral of 25 sine squared theta d theta. This is where things get a bit tricky now. Let's just simplify this to bring 25 outside, because we don't need it inside. Now this is where we'll need to use the trigonometry section of the formula booklet, and I'll show you why. So sine squared of theta, right? Naturally, you're going to tell me we can use the Pythagoras rule. Sine squared theta plus cosine theta is equal to 1. And this would not be a wrong assumption. Naturally, I would also think that. But then if we do that, sine squared of theta is equal to 1 minus cosine squared of theta. And the question is, how do we integrate sine squared of theta? I will show you why u substitution is wrong. Say u is equal to sine theta, right? du over d theta is cosine theta. So d theta is, hold up, let me solve this. D theta is du over cosine theta. And if we put that back in, we get 25 times u squared du over cosine theta. The question is, how are we going to solve an integral like this if we've still got this cosine of theta? We can't cancel that with anything, so u substitution does not hold. And the thing to note is you cannot integrate a trig function that is squared. You cannot. It's impossible. So what we need to do is use an identity which is found in the formula booklet. If you scroll up to the geometry section, you need to look at this formula here. So I'll just write it down. It's cosine of 2 theta is equal to 1 minus 2 sine squared theta. What we do is we solve for sine squared theta, so that would be cosine of 2 theta minus 1 negative 2 sine just solve for that. And let's just get rid of the negative sign. We put the negative, we get 1 minus cosine. And what I did here was essentially, I know I didn't explain it, my bad. What I did here was to get rid of this negative, I distributed it up here. So that would be negative cosine and then positive 1. So I just rearranged it to 1 minus cosine. So I hope that makes sense. And now, our 7th step is probably the most important step here. So just substitute that back in. So you get 1 minus cosine of 2 theta over 2 d theta. And let's take a pause, because let's see how long this question has been. It has been very long, and I've probably been solving it for more than 5 minutes. And the reason is, trig sub is not easy. It's not the type of question where it'll take you 3 minutes to solve. It can't, because IB will somehow twist the question so it takes longer. And the twist here was we had to convert sine squared of theta to all of this. We had to use the formula in the formula booklet for trig. So that's it. That's what makes it harder. So anyways, back to solving this. We get 1/2 minus cosine 2 theta over 2 d theta. And you can just rewrite this as 25 multiplied by the integral of 1/2 d theta minus the integral of cosine of 2 theta over 2 d theta. We will multiply the 25 to everything once we've simplified it. So if we simplify it, we get theta over 2. Oh yeah, okay, yeah, so my bad. Minus, now cosine of 2 theta. So we need to remember, this. When we integrate something, we go back to our parent function, our original one. So let's say, and the only way to integrate cosine of 2 theta is to have a lot of practice, because that would make it more natural. But what I like to think is, to get cosine, you need to start with sine, right? So let's say we start with sine of 2 theta. If we get the derivative of sine of 2 theta, that would be 2 cosine theta, or sorry, 2 cosine of 2 theta. But we just want cosine of 2 theta. So our parent function needs to be 1/2 sine of 2 theta. And this is all divided by 2. And we add c. And this is a very confusing step, and I'll explain it a little bit more. If we've got 1/2 sine of 2 theta, and we get the derivative of that, it would be 2 times that, which is 2 times half, which is 1. And derivative of sine, which is cosine of 2 theta. So you just gotta reverse engineer this process. It will come with practice, so I don't expect you to fully understand that yet. just see how I'm solving the problem. And we will get 25 over 2 theta minus 25 over 4 sine of 2 theta plus c, and we are not done yet, unfortunately. I told you, it is a very hard problem because we said x is 5 sine theta, right? So let's just write that down. X is equal to 5 sine theta. Okay, and I'm really sorry if this will take a lot of your time to watch, but it's important. So solving for theta, we get theta is arc sine of x divided by 5, yeah? So we just substitute that in, we get 25 over 2 arc sine of x over 5 minus 25 over 4 sine of 2 arc sine of x over 5. That does not work. It doesn't work, and that is because how can it work? How can we put sine and then arc sine inside of sine? This is not a good way to express your answer. So I'll show you that step as to how to solve it, and it's simple. Again, we need to go back to the triangle, and I'll just draw the other triangle here. And this is why drawing the triangle is the most important step in the entire trig sub. So I said this is 5 and this is x. So this would be 25 minus x squared. And I'll explain that because we have 5 squared plus x squared is equal to, say this is equal to k, right? This side, again, we use that example. We can say k squared plus x squared is equal to 5 squared. So k is 25 minus x squared and then square root that. So why is that important? It's because sine of 2 theta can be written in a different form. And that's in the formula booklet, right? It can be written as 2 sine theta cosine theta, which is equal to 2 sine theta. Sine theta is x over 5. Cosine theta is, wow, it's a lot, man. 25 minus x squared over 5. There we go. So if we put that in 25 over 4, we get 25 divided by 4 times 2x times this. We get 50 over 100 x, which is 1/2. So that's just x over 2 times 25 minus x squared. And finally, we get our answer, which is very simply just, I'll write here 25 arc sine of x minus 5 minus what we have here, x over 2 times the square root of 25 minus x squared plus c, and that is our answer for this integral up here. And you see, the answer we have here is not in the same form as what the formula booklet shows us. And that's because, as I said earlier, we've got this additional x squared. So this practice problem we did, watch it again and again and get comfortable with it. I don't expect you to master it, but what I do expect you to understand is everything we've done up here. All of these initial notes, especially for a problem like this, because this is very, honestly, I'll be honest, this question will not come in IB because it's too easy, but it will give you the baseline for trig substitution. You need to understand the different forms you can have, how to apply them, the unit circle, and just general trig, very basic trig. But yeah, that's all I have for you today. I hope you enjoyed the video, and please ask me questions if you got more.